the last issue to talk about in the discrete method is, will it always work? And the biggest issue in this case is there always enough money in the bank that is put there by the people who get over their fair share to pay out the people who have not yet reached their fair share? So if that's always true, then this will always work. So first we're going to start with some notation, the first of which I've already started. So T sub I is going to be the total that the collection of items is worth for person I. So if we go back to our previous example, T sub A is the total value of the island for person A, and I've written that's 180k. Similarly, the T sub B is going to be the total value of the island for person B is 150k, and T sub C we said is 12k. Okay, and the next notation I want to say is R sub I, and that's going to be representing result of the ith person. So that means R sub A is how much money in terms of items does person I get after the first round. So this is best to illustrate by example. R sub A would be 120 because after the first round of bidding, that's how much that person has in their pocket in terms of land or whatever these items might be. So R sub A is 120k. R sub B was how much? 60 and 20. It was 80k. And R sub C, we said that C didn't get anything here, so it's going to be 0. You can put K if you want. So that's going to be R sub I. And M is going to be number of players, simply. Because we're going to be doing this for an arbitrary number of players, not necessarily just 3 companies or 4 companies, just M companies or players. Okay, so with this, we are ready to kind of begin the proof or explanation here. So the first thing to keep in mind is that out of all the players, out of all these M players, they fall neatly into 2 categories. Either they're debtors, or they're creditors. So a debtor is going to be someone like A or B who needs to pay money out after the initial bidding round because the amount they have is more than their fair share, because 120k is more than 60k, because 80k is more than 50k. So debtors are going to be people for whom, we'll write it in simple terms, their result sub I is greater than their fair share. So that's true because result sub A was 120 and their fair share was 60, so that's true. Now creditors are just the opposite. Creditor is someone like C. That's someone who is being owed money because their result sub, let's say J, to distinguish from the debtors, is going to be less than their fair share. And that's true because the result sub C was 0 and the fair share was 4, so 0 is less than 4. Okay, so now let's try to get more into the math of this. Fair share, we're going to write this as a different way. So result sub I is greater than, fair share is what? That's going to be, fair share for A, for example, is total A divided by the number of players. So it's going to be TA over M. So instead of A, I should have written I, so I'll write it again. R sub I is greater than T sub I over M. And that's the definition of debtor in the most simple way. Creditor is just the opposite. It's going to be R sub J is less than T sub J over M. And that's the definition of creditor in the most simple terms. Okay, so let's hold on to that for a second and let's talk about a important relationship that will let the rest of this proof flow very simply. So here's a relationship. The relationship is going to be, we're going to try to prove that sum of the t's is less than or equal to m times sum of the r's. And sum of the t's is just t sub a plus t sub b plus t sub c plus t sub d plus all the totals for all the people, whether they're debtors or creditors. And sum of the r's is the results, so r sub a, r sub b, all of them added together for all the people, whether there's debtors or creditors. Let's try to prove this, and it'll be hopefully intuitive. So first, what is sum of the t? So sum of the t is going to be this number plus this number plus this number. And what is that really? That's really just the sum of every single entry in the table. Okay, so we'll write that in more common terms. It's the sum of all entries. Okay, now we're comparing that to m times the sum of the result. What is the sum of the result? Well, in this case, the sum of the results would be 100 plus 60 plus 20 plus 20, because that's all the numbers that we circled, and that's the ones that were given to each person. So the result of A is 120, result of B is 60 and 20. But notice something interesting here. In the orange row, what's the highest number? 100, and that's R. That's part of R. Now, what's the highest number in the red row? It's 60, and that's another component that we're adding to some of the R's. In the purple row, what's the highest number? It's 20, and that's another component. In the green row, highest number is 20. So, sum of R's can also be thought of as the sum of the highest number in each row. So that's going to be an important thing to note. So it's going to be m times sum of max in each row. Now let's do a little bit of a simple experiment to see why this relationship is true. Why is sum of t less than m times sum of r? So let's just do it for this example. Sum of t's is going to be what? It's going to be 180 plus 150 plus 12. 180 plus 150 plus 12, on parentheses, I'll put k out here. We're comparing that, we'll put a question mark because we don't know yet. We're comparing that to what? M was 3 in this case, times the sum of the max in each row. So it's going to be 100, 60, 20, 20. So it's going to be 100 plus 60 plus 20 plus 20. And let's actually expand this out because it's going to be instructive. 3 times 100 plus 3 times 60 plus 3 times 20 plus 3 times 20. And the reason I did that is because what is 3 times 100? How can you kind of illustrate that in this table? Well, that's going to be 100, and then what if this was 100k? And then what if this was 100k? That's going to be 3 times 100. Now, what is 3 times 60? That's going to be if this was 60, but also this was 60, and this was 60. Now, what is 3 times 20? That's going to be if this was 20, if this was 20, which it is, and this was 20. And again, 3 times 20, that's going to be if this was 20, this was 20, and this was 20. And then you add up all the red numbers. And so I'll put these red numbers here as well. So you're adding up all the red numbers, which is the maximum of each row. So you're adding up now 300s, 360s, 320s, 320s, instead of the lower numbers that were originally there. And that's going to be m times sum of r. And you see intuitively why that is going to be much greater than the original totals, because you're just maximizing each row and you're adding all of those up instead of adding up the original pink numbers that were underneath. So that's why intuitively sum of t is always less than or equal to m times sum of r, where it would be equal to only if all the pink numbers were already the same as the maximum. So these were already, the red numbers up here were already the pink numbers. There was no change, but that's not the case here. A lot of times the pink numbers are lower most of the time. So we have established this relationship. We established, and I'll write in a new color just to frame it. Sum of t is less than or equal to m times sum of r. And this is the most important relationship in this proof because it'll let us just flow through the rest of the proof. Let me get a new piece of paper. So let's rewrite that relationship. We have sum of the t's is less than or equal to m times the sum of the r's. And now to finish off this proof or explanation, we're going to split up this sum t and sum r into smaller components. So we're going to first do this. Sum of ti plus sum of tj is less than or equal to m times sum of ri plus sum of rj. So let me explain what I just did. Sum of t is the sum of everyone's t, the sum of the debtor's t and the creditor's t. And keep in mind that everybody's either a debtor or a creditor. And important thing to note is that you don't necessarily have to be either. And the last case is if the amount you received from the bidding round is exactly your fair share, in which case you're not expecting any money, you're not giving any money. But in that case, for the purpose of this example, we're just going to lump you in either case. It doesn't matter because your RI minus your fair share is going to be 0 anyway, so you're not going to affect it either way. So we're going to say that everyone is either a debtor or a creditor. And so sum of TI is the sum of the totals for the debtors, and sum of TJ is the sum of the totals for the creditors. And those together are the sum of the totals for everybody because everybody's a debtor or a creditor. And same thing here. This is m times sum of r. And sum of r is going to be sum of r for the debtors plus sum of r for the creditors. Okay? So next thing I'm going to do is divide by m on both sides to get the 1mth over here. So we're going to have 1 over m times sum of ti plus 1 over m sum of tj. Less than or equal to sum of ri plus sum of rj. Okay, and you're going to see why I put the 1mth here in just a second. So now we're going to rewrite this. We see we have an I on this side, j on this side, j on this side. Let's get the r's and let's get the i's and the j's on the same side, and then this will become a lot easier for us. So we're going to have sum of ri minus 1mth sum of ti is going to be on this side, and that's going to be greater than or equal to 1mth sum of tj minus sum of rj. Okay, so now since we have a sum on this side, we can put these sums together. So the first thing to do is take this 1mth and put it inside here. So let's do that. Sum of ri minus sum of 1mth tj. Since m is just a constant, we can just pull it inside. Sorry, this is an I. is greater than or equal to sum 1/mth Tj minus sum of Rj. And now since we have a sum here, we can just put the sums together. We get sum of Ri minus 1/mth sum of Ti greater than or equal to sum of 1/mth Tj minus Rj. So now you're probably thinking, what is this mess? Why is this helpful to us? So this is helpful to us because of this important relationship that we hinted at earlier. If you're a debtor, for every debtor, how much do they owe to the bank? Well, that's going to be how much they received. That's going to be their Ri minus their fair share amount. So that was true in the previous case because for debtor company A, their Ri was 120 and their fair share amount was 60. So they had to pay the difference, 120 minus 60. So in the same way, you have to pay Ri minus your Ti over number of players. And this is your fair share. Remember, if you're a creditor, how much are you expecting? Well, it's going to be kind of the opposite. It's going to be Tj over M minus Rj because it's your fair share amount minus how much you received. So for the case of company C, that was 4 minus 0. So they were expecting 4K. Okay, so now how much are all the debtors giving to the bank? This is just for one debtor, so we need to add up sum of all the debtors. That's how much they're all giving. It's going to be the sum of, debtor 1 plus debtor 2 plus debtor 3, so on. Now, how much are all the creditors expecting? Well, it's going to be sum of Tj over M minus Rj. That's how much they're all expecting. And what did we just find here? We found that this quantity is greater than or equal to this exact quantity here. Okay? And what does that imply? That implies that the money in the bank from the debtors is always greater than or equal to the amount the creditors need. And that's the most important thing because that means the bank is always going to have exactly enough or a surplus, as we saw in the previous example, amount of money. And that means this method always works.